So here we're looking at other roots besides square roots. So back to square roots for just a moment. Since 2 squared is equal to 4, then we know the square root of 4 is equal to 2. Now, there's nothing special about squaring things. Sometimes we need to cube things. So I might need to know 2 cubed, 2 times 2 times 2, that's 8. And just like there's a square root, there's a cube root. So undoing cubing something. And it looks like the square root symbol, but it's got whatever root we're taking, like the cube, in that little hook there. So the cubed root of 8 would be whatever number we raise to the 3rd power to get 8. And so the answer would have to be 2. Cube, 4th power, whatever, it doesn't really matter. We can keep going. So if I had 2 to the 4th power, that would be 2 times 2 times another 2 times 2, which would be 16. We can talk about the 4th root of a number. So the 4th root of 16, what number would you raise to the 4th power to get 16? That would have to be 2. And what I really want to check right now is getting these new roots, that's not too much different than a square root. We just got to realize that we're uncubing something, for example.
And I think Natalie and I both have calculators that do that.
Yeah, and then the question is, does your calculator have a root button or not? So that's what I wanted to show next, and then I'll mention that last problem. So, calculator, here we go. So my Desmos has that kind of button. So on my Desmos scientific calculator, which is a lot like my Casio calculator at home, I can hit the nth root button, and it says, what root do you want? I can say I want the 3rd root, and then I say I want the 3rd root of 8 by putting the 8 in the box, and they say, oh yeah, 2 is the answer. Okay, so you can do any root on this kind of calculator. If your calculator doesn't have that button, like my Google version of the calculator, which is like the calculator on my phone, I don't have a cube root button. And so here's the trick for calculators that don't have that button. The trick is, instead of a whole number power, a root is a fractional power. So for example, for square roots, I could say, what's 4 to the power 1/2? And the half part means the root. So a fractional power is a root. So fractional power, the denominator is the root. So if I wanted the cube root on my calculator, I would say, what's 8 to the power 1/3? And so on my Google calculator, I would type that as 8, and then I would ask for the power button, and I have to do parentheses 1/3 on my calculator. On my computer, it would look more like 8 raised to the power parentheses 1/3. So I'm just going to test that out on the Google calculator, make sure it agrees with what I believe.
It works on my $12 one even.
Okay, cool. So I'm going to take 8 and then raise it to the power as a fraction on my calculator. I need parentheses 1/3, enter, and it says, yeah, 2 is the cube root. So it's just a matter of figuring out how to master our calculators. All right, last problem of the day, and then we just need to compare answers, is the problem about the clay. And I'm just going to draw a picture as to how I would solve it. I'm not going to finish it, though. I'll let you guys do it. All right, so an artist is creating a sculpture using a sphere made of clay to represent the earth. And here we're given the formula for the volume of a sphere, a ball. Now he starts with this rectangular slab of clay that's 4 by 6 by 2. Just want to draw this out. So I'm starting with a rectangle that measures 4 by 6. Let's say the 6 goes out that way, by 2. So it looks something like this. It's my rough estimate. So there's my cube of clay, or my box of clay. And let's see, what are the units here? Make sure I don't mess that up. inches, inches, and inches. That's good. And then we want the radius in inches. So we're all good there. So I'm taking this box here, and the volume of a box like this is length times width times height. So its volume would just be 4 inches times 6 inches times 2 inches. So let's see, 4 times 6 is 24 times 2. So that's 48 cubic inches, or inches cubed. And we're going to mold this. We're going to take all of that clay and we're going to turn it into a sphere. And if we know the radius of the sphere, the distance from the center to the edge, then its volume is 4/3 pi r cubed. And so we want to know how big is the radius going to be if we use all of the clay. And the catch there is all of the clay means these guys have the same volume. So we want to know if we have a sphere, 4/3 pi times the radius cubed, and we use all of this clay, 48 cubic inches, what's r going to be? So we're just going to solve that for r. And it's kind of like that circle problem we did in the beginning, but we're going to have a cube root and a couple more steps. Okay, so I'm going to stop there. And then, let's see, we lost Brennan. That's okay. He had to go to practice. So it's up to Brenda and Natalie and Joe to solve the last few problems together and compare answers. And so that'd be the Pythagorean Theorem ones. So we have these 2 different situations. I always draw a picture when I'm doing the Pythagorean Theorem to make sure I put the numbers in the right spot.
Me
Right?
too.
Because we got to know which number is A, B, and C, and every problem is a little bit different. So so draw the picture out. And like earlier, sometimes when I draw my pictures, they're to scale. Sometimes they're not. I'm just mainly trying to get the numbers in the right spot. And then sometimes I'll draw it to scale to see if my numbers look reasonable. So that's sometimes a nice trick too. So no need for a breakout room. So I'm just going to let you guys talk amongst yourselves. And I'm just going to step away for a minute. I'll be right back.
I took many, many notes.
All right,
And we
so
did many, many problems.
So I got to this point here, like I mentioned earlier, by just realizing that I've got this much clay to work with. And to estimate how big my sphere is going to be based on this much clay, I just say, all right, this is the volume of clay I have. And I just set the sphere volume equation equal to it. So we okay up to there?
Yep.
Okay. So from here, I just need to solve for r. So a couple ways to do it. We could look at this 4/3 here, and there's 2 ways to get rid of it. One way is to what's called multiply by the reciprocal. So if I multiplied this by 3/4, the 3's are going to cancel and the 4's are going to cancel. So I would do the same thing on the other side. Multiply it by 3/4.
That's how you get the 36.
Yeah, and if you didn't like that step right there, if that's causing you fits, then alternative, I'll write down here. The alternative would be to say, okay, I want this 3 out of the denominator, so I'm just going to first multiply by 3. And then do the same thing on the other side. And 48 times 3, that's not too bad. So let's see. 4 times 3 is 12, so that's 120. 3 times 8 is what, 24, so that's 144.
Oh my gosh, that's really confusing me. I'm going to have to not listen right now.
Okay, feel free to ignore. So I could just say, let's get rid of the 3. Now I don't have a denominator. And then to finish this off, I would just need to divide by the 4. And then I could check on my calculator how many times does 4 go into 144. On the other side, the 4's cancel, leaving pi times the radius cubed. So let's see, 4 goes into 14, what, 3 times, with 2 left over. 4 goes into 24 6 times. So I get 36, which is similar to what's going to happen over here. I heard someone say earlier that they, on their calculator, they took 48 times 3/4, and they got 36. So 2 different ways to get to the same place. We're trying to get r alone, so we got to get rid of the pi. Now, my recommendation is, since pi is kind of a messy number, is to not use your calculator at this point, to just leave it as 36 over pi. So now I think that r cubed, because the pi is divided out, is equal to 36 over pi, and I'm just going to avoid my calculator for a minute. And then the last step to get rid of the cube root, or to get rid of the cube, is to take the cube root on both sides. And at this point, the cube and the root cancel, leaving just the r, and this, whatever the calculator says, is the answer. So this is the only exact answer, but that's not useful because I want to know, I want to measure this, right, like with a ruler. So I want my calculator to approximate this for me. And so now it's just a matter of carefully typing that in. So on my Desmos calculator, it has a cube root button. So I could just use, I guess I'll start over. Hit my button, it wants the root first, and then I can enter the number I want the root of, and that's the 36 divided by pi. And the trick here is we want to make sure the pi is inside of the root. Okay, and I get 2.25 roughly.
And a pitchfork.
And a pitchfork, whatever that is. On my other calculator, if you don't have that button, then you would have to go parentheses for the division, 36 over pi. There it is. And then close that to the power, parentheses 1/3. Some calculators need it this way, but I think most calculators, put on my mask, I get neighbors in the building. Most calculators have that cube root button. So 2.25, I get about the same way there too. We did it. Woo! So the radius of the sphere would be about 2¼ inches. That's the distance from the center of the edge. So the diameter would be like 4½ inches. So I think I drew my sphere a little bit too big compared to the clay I drew over here. Yeah, it would be a lot smaller than this one right here. Let's see, if I'm claiming that's 2 right there and that's 4. Suppose I was a little neater with my 4 and my 2 there. That would be 4¼ So this would be my sphere about this big. And my art is not good today. So that's more like about the size. It would have a diameter of about 4½ inches. All right, we did it. We kicked this activity in the pants. Congratulations.